Hello, everyone. Thank you for being here. So I will move to something closer to end users and specifically, but not so specific to social sciences. So it's a research tool that we are developing in the laboratory. I'm speaking in the behalf of my team, especially Etienne Lyon, Julien Bollard, Paul Girard, and other PhD students and who contributed to the software. And it is not Gen AI, but somehow it is AI, but kind of old AI, so BERT AI. So basically, we're trying to find a way to develop best practices for social sciences in our laboratories in social science. I'm not sure, because we are very heavily focused. PyData is quite more STEM conference for the background people. There is not a lot of social sciences, or at least it's what I can feel of the atmosphere. So I just want to give you a little background of why we are doing that. Text as data is becoming a huge thing in social sciences. And when I think social sciences, it is economics, sociology, management. There is a lot of disciplines in social sciences, and we have an explosion of content to analyze. So, of course, social media, newspapers, but also transcription from audio data. And this leads to a development of a lot of new methods coming from NLP, so natural language processing, that are kind of used now for a lot of different users, very high skills users that are doing programming, but also users that are not so quite familiar with programming skills. If you just want to have an idea of what's going on, recently there was a conference in Sweden called IC2S2. It is a conference dedicated for computational social science. And if you look at what has been told during this conference, there's a lot of text analysis, database crunching. And so it's a big thing to analyze textual data in social science. And this is all the more the case that since 2018 and again around 2022 with the GPTs, we have now a lot of open source models that we want to use to make all those treatments possible. So there is two generations. I'm just saying that because we are kind of developing solution based on the first generation. So the BERT models, BERT is for B for bidirectional, T is for transformer, so it's a transformer architecture, and it's kind of smaller models that huge LLMs that we are using for generative AI that are more based on GPT architecture. So basically, BERT are encoders only, and GPT are decoders. And so we have a proliferation of new models, and the consequences for the social sciences is a huge increase of different ways of analyzing data, which lead to unstabilized methods, and there is a need for new resources that are not so much available in the scientific communities, in social sciences, I'm thinking. So both specific coding skills, but also resources like GPU to make all those models available. So what we wanted to do is to try to do something for those kind of analysis. And just to give you some examples of what I mean by social science research using NLP practices, just a few examples, just for you to give you a small background of diverse kind of works that were published in the last 5 years. The first one, for instance, is studying the stance of opinions on global warming, trying to identify if it's more supportive or against the position of global warming is existing. Our team just published a paper about the way the concept of gender is used in the French scientific social science articles by analyzing all the abstract of the French publication, so it's more than 50,000 articles to identify how much the concept of gender is used in those publications. So it's the paper from Julien Bollard, Etienne Lyon, published recently, La part du genre, so the part of gender. And another example can be, for instance, a recently published paper from a public health team that is analyzing open text answers on surveys from where people get contaminated of COVID. So basically, just some kind of examples, and just for me to give you a bit of background, at the end, for instance, it allows the team, our team to analyze what kind of journals published the paper on gender, and to analyze that the part of paper that use the concept of gender didn't increase so much in the last 20 years. So it's just an illustration of uses we can have. So, of course, there is a lot of tools that exist to do the kind of treatment we want to do for text analysis, especially for annotation. And maybe you know some of them. You can find in the open source community the software Docano, software Label Studio, Argyle from Hugging Face. But somehow, the tools that are existing to analyze textual data, and more especially to make annotations, are not designed for social sciences. And they are covering a range of tasks, but not exactly, and not always suitable for people who are not experts of machine learning tasks and NLP analysis. And they are quite a bit far from non-expert users, especially social scientists or journalists. And on the other side, we have also, as a community, so sociologists, economists, some kind of a lack of a specific discussion and community about the tools we need for our research. So all of this is kind of the background that led to the inception and to the development of the software I'm going to talk about, which is called ActiveTigger. ActiveTigger is kind of a bad pun for tagging, but it's okay. We are just carrying on this technical debt, which is the name that has been chosen at the beginning. And it started, you know, as a small prototype based on Air Shiny, with some Python code inside it. And it was designed for a specific task. Basically, doing an annotation, of a data set to make classification, for, at the end, fine-tuning a BERT model, so basically a small model around 500 gigabytes, to make classification of textual data on large data sets. And it was designed especially by using also a loop of active learning, which is some kind of helping the user of selecting the elements that maximize the fine-tuning of the model downstream of the task. So it was the initial idea, and it was picked because it is a very frequent task for social sciences, being confronted by a huge data set of text and needed for one researcher, a small team, to be able to annotate and classify the whole data set. And the fact that even currently, with the spread of LLMs, the BERT fine-tuning is still state-of-the-art for a lot of tasks connected to classification of text data. So this was kind of the idea behind ActiveTigger, and first a prototype was developed, and early users started to adopt it, and we had the decision to make it a bit more, you know, more well-developed, and to rewrite it in Python, and adding the possibility to have collaboration, to be able to collaborate on annotation of textual data. And after that, we started to add different features to this new tool. So basically, the tool started in 2023, and we started to rewrite it entirely in Python and web technology around 2024. Our main goal by doing so are the following. First, ActiveTigger as a tool, and I will come to a demo because it's more easy to identify what is the aim of this tool by seeing it in action, is a tool to accelerate classified training to scale annotation on large corpus. But besides that, besides doing the task of classification, it is also aiming to give the user the possibility to evaluate how good is this classification, because at the end of the day, people want to publish a paper in social sciences journal, and so they need to compute a lot of metrics to guarantee that the classification is good enough to be published as a scientific results. The third goals we were following by doing the software is to limit as possible the dependency to external services, especially now with the rise of LLM-as-a-service, to need to be dependent of providers, especially private providers, for accessing endpoints. And so we are still trying to use a maximum BERT models that can be used on small servers, or at least GPUs that are not quite so big, to be affordable for research laboratories. The next goal was also to maximize the possibility to be pedagogical, because our communities, especially in social sciences, are part of and composed of users that are not trained for machine learning or for deep learning. And then, of course, we wanted to promote open source and open source research tools, or the complete stack is developed with open tools, and to stimulate a community discussion on the best practices we need in the future. So it is basically, the global idea which were behind the development of ActiveTigger. So you can find all the code and the Docker and the quasi-stable version on the GitHub, which is for the moment in my GitHub, but will be moved to the institutional GitHub sooner. And just to give you a hint of what's behind, it's a basic architecture with Python in the backend, leveraging different Python packages like scikit-learn, transformers, and so on to do all the computation, and a front-end that is developed in React to be able to adjust and to adapt a user-friendly interface. The idea is to be closer to the user's practices. For instance, we will be trying to make it suitable for smartphone users, because a lot of researchers, PhD students, postdoctoral students are just annotating data during the transportation in the morning. So we want to get closer to what people are really doing, with text data in research. And of course, we are going to do the software designed to do fine-tuning of models. So needs at least some kind of computational power, and it's better to have a GPU. So it is mainly designed to be hosted as a service for users, but it can also be run on-premise on personal computer, because in a lot of cases you don't want your data to go outside of your own computer or your secure installation. So basically, this is just an overview of the architecture, but please, if you want to discuss about it, you can discuss. So I just want to do a small demo time on what is ActiveTigger, to give you an idea of its uses and how you can use it. I just using a small example, which is basically where we are at PyData. If you are looking on all the scientific publication on open databases like OpenAlex, you have a lot of publication about Python in general. And so maybe, and something you can want to train a classifier that is classifying publication as suitable for PyData submission or not. So it's a very basic task, but I can guess you can imagine other tasks like this in the future. So basically, if you go on OpenAlex, which is a huge database of open and non-open publication, you have around, 70,000 publications around, and you can download the abstracts, and then you want to classify all the publications are either suitable for PyData submission or not. So it's beyond the possibility of a human to annotate everything, so you want to train a classifier. So you have the idea. You want to train rapidly a classifier to just classify these 70,000. In fact, it's a bit less, because if you filter all the anti-abstracts, you have less elements, but this 10 of thousands elements of the dataset. So if you want to connect, please scan the QR code or go on the page. You have an account PyData 2025 to connect, but I will do it in live, just to give you a quite a small presentation of the application. Okay, so just wait a few seconds. If someone wants to connect, please join, but just to have an overview. So basically, ActiveTigger is a web client. You have also a Python client to connect, and you can go on a project. It's a collaborative project management, so you can create project, add users on it. I won't go through all the process, and so I create a project, which is basically a data set of all abstracts mentioning Python published or available on OpenAlex. So I already created the project, but the idea, once you create a project, you want to be able to train a classifier. So both you want to have a trained data set and you want to have a test data set. So the idea of the software is to help the user, to follow the best practice of separating a train dataset, then a test dataset, then annotating the test elements at the end of the process, and to get the result, especially the F1, to be able to certify at least a bit that the classifier is strong enough to generalize on the complete dataset. Okay, the idea of the software is to automatically then compute a few elements, like the features, and behind the software, in the API, there is embeddings of the text that are computed. So each text has its vector of dense elements that allows to do some machine learning on it. And then once you have that, you can start to annotate. So if you want to join and to annotate elements, you can do, but the idea is just to help a quick annotation of suitable or not suitable articles on Python for PyData. For instance, we know that there is a lot of articles that will discuss about Python as a snake. So maybe if we look for snake, we can quickly, flag a few of them as being not very PyData compatible. At least we need to have a check on it, but in this specific case, it's not PyData. The other one, the identification, a novel data virus in boa constrictor, is not really PyData, and so on. So okay, I won't do it completely, but if we are 3 or 4, it's quite easy to start to annotate a few of the abstracts, and here we have 28 abstracts annotated, and then with this small data set, we can start to train the first model, so a first machine learning model that is able to predict, at least to give an indication, how much the other elements which are not annotated are in one or the other category. In specific case, I already trained one, so I train a small linear model. I will retrain it now. So basically, I have a predictor that can classify each element as either PyData or not PyData. So this one is a bit better than the previous one. So it's a very bad F1, you can see it. So maybe we need to annotate more. And then we can start to have a loop of active learning, like starting to annotating a few elements, and then training a small model, then annotating more elements, using the indication of the smaller predictor to be able to focus on categories that are not already in the annotation, the annotated dataset. And the idea is to continue this way until to be able to train, to fine-tune a BERT model with the annotated elements. So in this specific case, I already launched one, so I will launch another one again. So I can create a new fine-tune of the model. Let's call it PyData. I can choose the base, like the vanilla models I will use to make the fine-tuning. So it's all open models, open BERT models. So we had an update recently, a few months, with the new modern BERT that updated a bit the architecture and makes them a bit smaller and quicker in inference. But we can take old ones, like in French, we have the camembert, but in this specific case, we have more English written text. So let's take, let's keep with the modern BERT base, which is a small, like 400 megabytes model sequence fine-tune. There are a lot of parameters to change, and of course, the user needs a bit of experience of how to choose the hyperparameters of the fine-tune. And in specific case, we are running the instance of the server on our laboratory computer, which basically has a 40 gigabyte GPU available for the users. So now you can train a model, and every computation is done on the GPU. And because I didn't change a lot the annotation dataset, we'll have something quite equivalent of the previous one. So you have a classifier with quite bad elements. And so in this specific case, it's not good enough to generalize. So maybe we can go back to the annotation section and continue to annotate the dataset until we have good enough metrics to start the inference on the global dataset. So this is a quite rapid overview of the main pipeline for which was designed ActiveTigger. Of course, we are starting to add other features because since the Gen AI hype is going on, we have no new possibilities to do information extraction, classification, and in the future span detection. So we are starting to add in new possibilities. For instance, in a lot of projects, you want to have a quick look of the content of your dataset. And in the NLP community, the package BERT-like get a lot of influence recently. So a lot of users want to do a quick topic modeling of the dataset. So we added the possibility to add topic modeling of your complete dataset, and then to go a bit across all the abstract, all the elements of the training dataset, and to have an idea of what's in it. In this case, you can identify that you have a complete specific cluster of snakes. No, it's not snakes, this one. It's something else. So basically, we are starting to build around this main pipeline of training a classifier by adding a new features. And the last one, which is still kind of in development, is to add the possibility to use a query on the LLM, which in a specific case will be run on an external services, and then to use basic prompt engineering. So in specific case, I have a prompt here, and just run this prompt against another services to extract information or to start a classification, with the idea that we can then reuse this classification for training a BERT model and, for instance, expand the annotation on larger dataset where LLM could be a bit slower to be able to scale completely. So I gave you just a basic idea of the app. We'll just conclude that saying we are moving for first stable version by the end of the year. And it's something which has been thought mainly for social sciences, but can be used beyond, especially, for instance, by journalists, but by all the users that need at some point to annotate datasets. So thank you for your attention, and please ask if you want to use the software on our instance.
Sorry, I'm late. So thank you for your presentation. Do you have any questions in the room? Yes.
Thanks for the great talk, Emilia. One question, is it possible for two different people to annotate the same text? And if so, would you provide the inter-annotator agreement? Because it is something very interesting usually in annotation.
In this case, there is no possibility in the same time, so it's not synchronous, but two annotators can annotate, asynchronously the same text, and there is different agreements that can be computed, either for one specific annotation scheme or beyond different annotation schemes regarding some conditions. So the idea is to, there are some for the moment, but the idea is to add all the indicators and metrics that at some time we need as a team, as a researcher, or as a user to publish a strong result and to justify, this kind of scaling classification on large datasets.
Any other questions? Going down, so I can see. I can better see.
I don't think so.
Nope. So, well, thank you very much.
Thank you.
And I think we can all move to the break with a bit of advance. That's nice. Let's thank you again, our speaker.